The binomial theorem is used to expand binomials raised to powers. Now, before I can teach you how to do the problems, I'd like to give you a little background. Let's see, x plus y squared. If you don't understand how I'm getting this one, just go ahead and FOIL that or double distribute it. All right. X plus y cubed might be a little bit harder. In fact, we would probably put this in front of the one above there and then distribute. So let's take a little bit of time and do that. X cubed plus 2x squared y plus x. Y squared plus x squared y plus 2xy squared plus y cubed. Now I do have some like terms there, so let's go ahead and clean this up. X cubed plus 3x squared y plus 3xy squared plus y cubed. Now, just for the sake of my sanity, being able to see these, I'm just going to draw light lines through those so I know x to the cubed is that. Now, you may have heard of or seen Pascal's triangle before, but I want you to remember how that works. All right, there's always ones on the outside, and then we add. 1 plus 1 is 2. 1's on the outside. 1. 1 plus 2 is 3. 3. 1. 1, 4, 6, 4, 1. And this pattern could continue forever. Now let's see what we've got here. 1x plus 1y. All right. 1x squared plus 2xy plus 1. 1, 2, 1. Does that pattern hold on the next one? 1, 3, 3, 1. Huh. All right. Well, I'm trying to save myself a little bit of work here. I don't want to have to distribute and combine like terms every time because it gets huge and there is a pattern. Now, because of Pascal's triangle, I know what my coefficients are going to be, but I need to figure out my variables. So let's see if there's a pattern. X to the third squared 1, no x. Let's look at our y's. Y, no y. Y to the first, y to the second, y to the third. So I'm wondering if I can therefore say that I'm going to have 1. We know we're on the x to the fourth term, plus 4, if my pattern holds, 3, 1 power less. And then how do I know for sure what goes here? There's a double check. If this exponent is 4, each term's exponents need to add to 4. That adds to 4. 3 plus 1 is 4. Let's look up at our x cubed. See how I've got a cubed? I've got 2 plus 1 is 3. 1 plus 2 is 3, and a 3. Okay, so that's a good double check. I know my next number is going to be 6. X to the 4, 3, 2. And my y's are going up. 2 plus what is 4? 2. I know my next coefficient is 4. X's are going down. Y's are going up. Plus 1, no x, but my y's are going up. That is the binomial theorem. Little background, I guess. Now, I want to show you some of your problems that you'll be working on. Now, you're going to have something like 3q minus p raised to the 16th, and then they'll say find the term that has the variables q to the third, p to the 13th. Now, there is a formula that you can look at and memorize on ALEKS, and sometimes it's easier to just see the process, and that's what I'm going to show you right now. You're going to use factorials, so if you haven't found the factorial button on your calculator, you're going to want to do that. This is our Q term, right? That makes sense. And this is our P term. You are going to need to include that negative. And so our coefficient, we're not going to do Pascal's triangle out forever. Our factorials can help us figure that out. We're going to do combinations. So because this is the power of 16, I'll put 16 on top. And then I have 3 factorial, 13 factorial. Those came directly from the term given, right? Here's my raised to the power, the Q to the 3rd term, and the P to the 13th term. They are. And notice they add up to 16. And then our Q term is this guy, including the 3. So that would be 3Q raised to the 3rd power times my P term is negative P raised to the 13th. Now I've got to simplify this. Now you can grab your calculator and you can figure those out. You might remember that I like to go 16 times 15 times 14, 13, 12, right? 11, 10, 9, 8 would cancel out the 13 factorial. Then I've got 3 times 2 times 1. And then I just like to reduce. I don't know. I kind of like to do that. 16 times 5 times 7. 5 times 7. And I get 560. That was this term right here, right? Now I've got times, let's simplify this, 27Q to the 3rd. And what is a negative 1 raised to the 13th? It's a negative 1, right? P to the 13th. Now let's simplify this. I've got 560 times 27 times negative 1, and I get negative 15,120 Q to the 3rd, P to the 13th. And you're going to find that those numbers get big quickly, so don't worry about that. Let's do another problem. All right, I have P minus 2x to the 18th, and it asks for the P to the 17th x term. All right, I take my power, and then I've got 17, 1, and then my P term is this guy, so times P raised to the 17th. My x term is the whole thing, including the negative. So negative 2x raised to the 1st. I know 18 factorial will cancel down from 17 with the 17 factorial. And then this would be times P to the 17th, negative 2x. And I get negative 36 P to the 17th x. We'll do one more problem and call it good. 2z plus x raised to the 25th, and it is asking for the z to the 4th, x to the 21st term. How do I do it? 25 factorial over 4 factorial, 21 factorial. And then I take my z term and I raise it to the 4th. I take my x term and raise it to the 21st. And this time it's positive. Yes? All right, so I know 25 times 24 times 23 times 22 is going to cancel with 21 down, or grab your calculator, use your factorial button. This is 4 times 3 times 2. Well, that is 24. So that can cancel with that. And now I have 25 times 23 times 22, and I get 12,650. 2 to the 4th is 16, z to the 4th, x to the 21st. Now I need to do 12,650 times 16. I get 202,400, z to the 4th, x to the 21st. Good luck on this assignment.